Alright, everybody. So here we are with our next talk, and this is going to be practical problem solving with the power of CAD and 3D printing with Kilk. Do remember that the discussion and questions are all happening on our Discord. There's a link down below the stream. And once you join, it takes a minute to get all the roles, but it should be all automated. And so do join us and get engaged. And we'll get this going now. So you are all set, and it's all yours, Kilk.
All right, thank you. Hello, everybody. My name's Kilk, and I'll be presenting practical problem solving with CAD and 3D printing today. So, what is computer-assisted design, or CAD? CAD software is used mainly for 2D technical drawings or parametric modeling to visualize designs in a 3D computer environment. Using CAD software, we can simulate stress, tolerance, joint actions, or the aerodynamics of a cow. CAD is widely used by engineers, architects, game devs, artists, 3D printer enthusiasts, and so much more. So, what is involved in practical problem solving when it comes to CAD? I've broken it down into 3 phases, which include the planning phase, the prototyping phase, and the production phase. So, those phases derived from the NASA's standardized workflow for the engineering design process. I specifically chose these 3 phases as we are not building a full-scale rocket today, but rather a more simple problem. A problem that started when I broke the enclosure for my dad's LCD screen. Hopefully he won't notice. So, in the planning phase, you have to identify a problem. Problems can come in all sorts of sizes and shapes. The more complex they are, the more time-consuming it can be. When you're finding requirements, you're looking for what to solve with your design. With constraints, on the other hand, you have to think about it in 2 parts. You're usually constrained on materials, weight, cost, and size. Another constraint to take into account is the tools that are available. Because normally, you wouldn't be able to purchase a $74,000 milling machine on Amazon and return it in 30 days. Instead, you'll have access to a 3D printer, which in more recent years has become more affordable to the common consumer. During the planning phase, I like to draft many designs using pencils and paper. It helps me have the visual and kinesthetic experience during the drafting period. A common mistake with the planning phase is trying to over-engineer a simple solution to a problem. Just because something is complex doesn't mean it's good. The more complex it is, the more room there is for error, human error. The reason this will occur is due to skipping over finding the requirements and constraints. Because when you don't have that, you're just going to think, oh, I can make the biggest thing possible, and over dramatics. So, some tools of the trade. Some tools of the trade that are used often when designing in an engineering environment include a vernier caliper, ruler, preferably a machinist's ruler, measuring tape, and pencils and paper. Vernier caliper is one of the most frequently used tools in the engineering field. It can help get a lot of specific measurements when designing around an object. A ruler is your true friend when you're measuring the length and width. It is vital that you know how to read and use a ruler. There have been many cases where I've been out in the field and there's people that don't know how to use a ruler. So when you're working on a project, a large one anyways, you usually use a measuring tape. It's because usually it's bigger than a ruler. So for example, if you're building a table or a welding booth, that's where it would come in use. So the last tool, I can't stress it enough, is pencils and paper. Making on-the-spot observations and designing on the go can be vital to a project. You can also jot down ideas based on your findings while you're outside on the field. So, this was the diagram I used to get accurate measurements of my screen. Note that it says units are in millimeters. Also, this is a JPEG. I drew out the circuit board in this example to design around it. And this is the dimensions. This is where the hole was, or the dimensions when I did the mirror. So, this is the second drawing I used when I got from the first one. I took that first drawing and I built around that drawing. So, During the prototyping phase, there's two phases I like to think about. The first phase is to be fast, cheap, and efficient in testing. During the second phase, you can add your final touches to make the product much nicer. Like you can add fillets or, curves and whatever you want to make it nice. During the first phase of prototyping, you'll choose a design from your drafts. You'll build it in CAD and then 3D print it. After you've printed your test print, write down observations such as what worked and what didn't work. After writing these down, you can go back to the drawing board and reiterate your design. It is important to realize that the planning phase and the prototyping phase go hand in hand together. Once you've gone through a couple of iterations and you're happy with it, then you can move on to the second phase of prototyping. So, during the second phase of prototyping, you can add fillets to make your design smoother and not as rigid. You can also add more structure or even swap materials out and see what works. Usually this is good because if you start with plastic, it's a lot cheaper than using steel or aluminum. Stock, yeah. So, this was the first iteration of my design when I was designing around a LCD screen. I ran into a couple of issues. The cutout for the HDMI cable was not tall enough, and it needed to be adjusted in the next iteration. The other thing was the hole for these pegs here weren't 3D printed. I had to tap into it, which ended up cracking the print. So, best warning, don't drill into 3D prints. It's better to just print it all outright and then put in like one of the thread things. I don't remember what it's called. The pegs were also not connected to the wall. As you can see here, this little area, it's not connected, so it wasn't as structurally sound, and it was really easy to snap off. So, during the second iteration, the filament broke while I was 3D printing. An important thing to know when 3D printing, make sure you keep your filament in an area where the heat and the moisture isn't constantly changing. You want to keep it in a controlled environment or it will not last as long and become brittle and weak. But luckily, I was still able to gather information based off of this half print. So I found out that the adjustment I had made was still not enough to fix it. And also, I connected the pegs to the walls and they were a lot sturdier, and that was great. So, the production phase is the result of the combination of the planning and prototyping phase. During the production phase, you can add your finishing touches, such as sanding to smooth out your print. You could put it in an acetone gas chamber to, melt it a little bit and smooth again. That's another way of doing it. You can paint it. You can use a Dremel and Dremel out a name or whatever you want. You can add logos, etc. So, we're going to move on to Fusion 360. Let's open that up. So, this is what the UI will usually look like when you start it up. One of my complaints with Fusion 360 is every time they update, the UI changes, and that's really, really annoying. But anyways, let's get started, shall we? So, with the middle mouse button, if you press it and you drag around the screen, that's how you move around. If you hold Shift and the middle mouse button, you can orbit around the origin point or the middle of the screen. So this top thing here is, I call it the navigation cube. Very important. If you, let's say, I went really far away from the building plate, hit the home button, now I'm back at the origin. Another thing is, if I want to build from the top view, you hit the top view. If you want to go to the right view, and then you hit this thing to rotate 90 degrees. So now we're looking at the right in the right way. The front, bottom, left, back. It's important that you use this. This is very important. So right now we are in the design workspace. Usually this is where we sketch out our models and then we extrude, put our cuts, add fillets, you maybe chamfer, add holes, maybe do a rotate if you're doing like a lamp or something. Whatever you're doing, the design workspace is where you're going to start. So to make a new file, if you want to make a new design, you hit New Design, and there we go. We have a new window for a new design. Another thing is right here where the browser. You drop it down. Usually, it's important that your document settings are in millimeters. The metric system rules. You want to hit the icon right here next to the units. Millimeters, or it's usually going to be in inches. That's what it starts out as, and you want to change it to millimeters. That is very important because if we're working with inches, and let's say we're modeling something small, and we say like, oh, let's just dimension it by 5. You're not dimensioning it by 5 millimeters. You're dimensioning it by 5 inches, which is completely different. That is huge in comparison. So let's create our first sketch. So this icon in the top left here says create sketch. Click it. So now you'll see this. What the heck is this? Well, basically it's asking you which plane or like which view do you want to start your sketch on. From depending on what you're building, you could build it from the front, from the right, from the back, left, and bottom. It's like all over these faces. But for today's purpose, we're going to start from the top view. So once you hit the top view right here, it should look like this. You want to click the top here. So now we are sketching on the top view, and your menu should look like this. Now you have this sketch palette here. Another important thing to note is look at the bottom here. You see what this is? This is the timeline, and just added a sketch. So let's sketch out something very simple. Let's create a box. So right here is a 2-point rectangle. It is recommended you start from the origin. Do not start anywhere else. That is a pain in the ass. I can't explain all the reasons why it's bad. It's just bad. Don't do it. Don't do it at all. So start from the middle point here and just drag out a box. So currently the only constraints is the horizontal and vertical. So basically this will be vertical no matter what you do, unless you remove it. If you click on that little icon there and hit delete, you can drag this around everywhere now. But if we go back to here and we add a constraint, the horizontal constraint, now you can't move it randomly and whatever. So this cube has no square has no constraints. Let's add some. So we can add a dimension. So you see where if we drop down the create menu and we go down here, it says sketch dimension. Click on one side and maybe click on the other. So now between those 2 points, you're going to dimension how long it is, or how long the distance between those are. So let's make it 25 millimeters. So now we've just halved it because it was at 50 when we placed it down. So now no matter how much we move it, it will always stay, these two edges will always stay 25 millimeters apart. So let's do the same thing for this top and bottom. So we were originally using this, but press D, and now we are dimensioning. So this, and boom. We are now dimensioning this distance between this top edge and this bottom edge. Let's do 25 millimeters. So now this is a 25 by 25 millimeter square. This is really tiny. This is not big. But once we've done that, we can hit finish sketch. Huzzah, your first sketch you've ever done. So this is important to know. If your sketch for some reason doesn't show up, maybe it's because if you drop down the folder here, and if you see the eye icon slashed out, it means your sketch isn't showing up. You want to click that. This is important because if we're selecting for an extrusion, we need to see that sketch. So hit the extrusion, and now we are going to be pushing the image into 3D. It's like Play-Doh, for example. You know, like the little shape tools where you plug in the cylinder of Play-Doh and out comes the star. That's what we're doing, but we're sketching out the mold for that. So we're going to make this 25 millimeters tall. So now this is a perfect 25 by 25 by 25 cube. Amazing. You've created your first 3D object. Now let's do more to this. So cool thing I like to do a lot is to create sketches on top of my 3D objects to do more complex cuts. So let's do one. So we're going to create a sketch, and instead of using the planes of the world, we're going to use the face of the object we've just done. So look down here. See this? So we've created a sketch. That was the first sketch. Now we've extruded it. Let me show you the sketch extrusion, and then we're creating a sketch on top of that face. So if we go back, right, now it's just a sketch. We go here. Now it's the cube because we've extruded. This is really useful because you can go back in your steps and see what you've done if you've forgotten, because you've come back to a project that you didn't work on for like 3 months. Very useful. So in this sketch, let's double click it. So you'll know you're in sketch mode when it has this green check mark where it says finish sketch, or this thing comes out, the sketch palette. Alright, give me a sec. So, since we have this selected, right, it's going, notice how this infinite grid moved up to this face. That's because when we selected the face, it's going to move the sketching plane to this face that we selected, and that's very important that we know that. All right, so want to create a hole. Let's create a hole. So yeah, remember, middle mouse to drag around. If you hold shift and you click a point and you middle mouse, you're gonna orbit. Oh wait, that didn't work. What the hell? Sorry, give me a sec. Whatever, we'll figure it out. Just holding shift in the middle mouse and you're going to be orbiting around that origin point, which is, again, why it's important to just build off of that so you can orbit around your object. Or you can use this cube here. So anyways, we're going to create a sketch on top of this cube. Let's create a circle. And let's just put it, God knows where. Just put it there, right? Let's dimension this. So it's going to dimension it by the diameter of the circle. So we're going to make it 15 millimeters. Why not? So this has no constraints at all, and so that means it's free to go anywhere we want, but we don't want that. We want to constrain it, so from the center point to this top edge, it has to be 0.1 millimeters away. Yeah, wait, we might want to do just 1 millimeter, why not? Right, so now if we look closely, from this middle point to here, it's 1 millimeter. Actually, that's not... I think there's a better way of doing this. Let's do that instead. All right. Instead of using dimensions directly with a circle and the square, let's do something better. We're gonna create construction lines and add constraints to them to make it easier for you to dimension based off of the circumference of the circle instead of using the center point. So we can do this by hitting 2-point rectangle. Actually, no, we're gonna use the line tool. Sorry, line tool. And you see where it says construction? Hit that. And drag out. You can drag it out there. And let's just do... So we're going to create our first constraint here. So you see where it says tangent? Click this line and click the circle. So if you know what a tangent is, where the line only meets the circle at one point, that's all you need to know. That's important. What we can do here is, let's create another line. And let's just put it right to the line here. So right here, what it's about to do is automatically give... Oh, it gave it a parallel constraint automatically due to this. But what we needed to do was have this be tangent to that. So let's just do tangent to there. So now both of these lines are tangent and these lines are parallel to each other. You can tell because if you zoom in here, that is the parallel constraint right here. Alright, the next thing we want to do is connect these two lines together. So let's add that. And let's add another line here. Alright, let's say we've accidentally overshot the line, right? Let's do that real quick. Let's just say we overshot the line, right? Well, we can hit whoop, I just did it already. So if you hit T, you open up the trim tool. This is really useful. Sometimes if you make sketches and the line isn't segmented correctly, it will usually not fill it and you won't be able to extrude it. So what you have to do is go back into your sketch and trim it and then refill it like this, right? So now this is complete. This is a cube and these 2 points are tangent. So what I was trying to show you is, oh my gosh, was to make it so we can use the circumference. What we can do is hit that edge, hit the circle, and hit the tangent, hit this edge, and hit the circle, and hit the tangent. So now we have a boundary around this circle where there's a line at one point, at the furthest point of the circle at the top here, where it meets it at one point. So basically, now if we dimension this from here, we are not dimensioning it from the center point, we are dimensioning it from the circumference. And I'm going to make this a 1 millimeter. Oh, whoa, where did that go? That is not right. Give it a second. Stop dimensioning, please. There you go. Press escape if you want to cancel an operation like that. Let's just drag our circle in here. Right? What is it doing here? Huh. What? Sorry, give me a second. I'm trying to figure out what the heck's going in here. Oh, that's right. These need to be, what you need to do is make sure that these are also vertical. So now they can't move at all. Oh wait, they can't. And these need to have the horizontal thing. So now it'll be perfect, except there's a problem here. This is not coincident. We're going to just trim that. So now it's perfect, except damn it. There we go. There we go. It should stay there and should move like that. All right. So we selected the middle circle. You stupid program. Let's just rotate around. All right. So we're gonna dimension from this to here, and that is about 5 millimeters. What happens if we make it 1 millimeter? So now this is completely 1 millimeter away. How about we want to make this as far away as possible? Let's make it 6, right? So a common mistake that probably will happen if you're trying this out is to try to dimension this as well. You don't need to do that because this is constantly telling it that it needs to say 6 millimeters away, and because that's defined like that, it'll automatically figure out how. Also, because we know this is 25 millimeters. If this is 6, then that means it's 19. From here to here is 19 millimeters, and the circle we know is 15, right? So if you write it like that, so 6 plus that's 21. So then this is from here to here is 8 millimeters, and it already knows that. So yeah. So now we can finish the sketch. Before we do that, maybe we want to change the circle's circumference. The circle's diameter. So what we can do is you can edit the dimensions that you place down by double clicking on it, and you can type in 10. So now it's smaller, and it's going to stay, because of these constraints we put here, it's going to still keep it, except now this is going to be 16, I think this is 9 now. Wait, I don't remember. I'm not going to do it off the top of my head. But yeah, that's all you need to know. So now we can do finish sketch. So now we have the sketch on top of this circle. What can we do with it? Well, let's do an extruded cut. So with the extrusion, we're creating an extrusion. What we did for the first one was we created an extrusion based off of the sketch. So basically, once we do an extrusion based off of the sketch here, what we can do is click this. We can do a cut, right? Well, when we did the first one, we did a new body. We were creating a new sketch based off of that. Based off of the we were creating a new object based off of that sketch by pushing through like imagine pushing through material through the sketch. But this time we're doing it off of a sketch on the face of the object, and where you could do join instead because we're joining these two together. I think that's important that you know that it's not new body, it's join. I think that is important when you're doing the 3D printing, because if you do it by new body, I think it doesn't add enough support. Not fully sure because I'm not capable of saying I am 100% fully experienced with 3D printing. I am an amateur at best, but that's what I'll say. So if we type in -10, see what it does. It's still doing the join. So we want to do a cut, right? So as long as how far this goes down, it will cut into it. So it'll do a difference operation. If you use Blender, it's called a Boolean modifier, and this is what it looks like. So it's basically just removing what you're extruding down. You're removing whatever's in there, which is important. So yeah, now we have this hole in here. That's really cool. So you've created your first cube with a hole in it. Let's do more stuff to this, shall we? So let's make this all fancy and stuff. Let's use modifiers. So when using the shell modifier, what it will do is what happens if I do 1 again? Basically, it'll take the offset of the faces and like kind of offsets the faces inside and makes like how Legos, when you look in the underside and they're like shelled, that's basically what we're doing here. It's kind of like creating Legos. It's making a shell based off of the object. So we can do a shell here. We'll make it 2. Yeah, there you go. I know this is probably making somebody not happy because this is not perfectly centered, but yeah, there you go. That's a shell operation. And so now we have there you go. So if you look here, see there's a offset from the bottom of that circle. It creates an offset off of that and creates more faces or more material here, because we've done a shell. It's like extruding all the faces by the normals, if you know what I'm talking about. Another thing to know is the fillet. You'll see a lot of memes about this if you ever do CAD stuff, because if you're like noobs or people like that, they love adding fillets to make it all look all modernized and smooth and nice and fancy. So what we did here was we added a fillet that was 3 millimeters. The way that you want to think about this is, imagine there's a point here and it's rounding this by a radius. So we're rounding it by 3 millimeters. So we hit that. Boom. There we go. We have a curved one. Another thing, we're going to do another sketch actually. So let's hit the front view now this time, and let's hit create sketch, and let's select this face right here. So now it's going to create this infinite grid based off of the location in space where this plane is. So we can hit front, and let's do a rectangle this time, and we're just gonna dimension it like that. We'll make this 15 millimeters. Oh, not 125. See, this is why you want to double click and just hit 15. There you go. And dimension here, 10. Also, another thing to note, when you're creating a 2-point rectangle, it automatically gives you these horizontal and vertical ones. And so basically what it's saying, no matter where the position is, it's always going to be perfectly vertical and perfectly horizontal based on which edge it is. Oh, man, that's a lot to say in one sentence. Anyways, so we can dimension this based off of this height here. Let's just make it 5 millimeters away. And from this wall, we'll make it, oh, wait, there could be something that might be useful. Let's first find the dimensions of the, never mind, don't do that. Use the inspect. Oh, wait, that didn't measure. There we go. So, here's a tool I just used. If you click here and you hit measure, which is I, so if you hit I because you're inspecting it and you select an edge, it's going to, well, if it works properly, can you work, please? If you click this, it'll tell you the length. And now if you select 2 edges, it'll tell you how far they are. This is useful because if you do something like, I want to know how deep this hole is because I forgot how deep it was. If you click the top ring and then the bottom ring, it'll tell you exactly how far away it is, so you know it's 10 millimeters deep. So that's cool. So we know this is 19, right? This top edge. How about we dimension this by doing 19 divided by 2, right? So now it's going to put it in the center, in the middle. Now see, now it's overstretching because it's not constrained to this. We can do here, and let's just make it. Oh, this is going to be a problem. So sometimes you don't want to constrain that. don't you can delete that, and so now you can freely move it again because there's no constraint. What we can do here is hit these 2 lines, and let's add a constraint called equal. That didn't work. Let's add coincident or coincide. Yeah, you know what I mean. Basically, you click that point, you click the line, and so this point here will coincide with this, and so that means you can't move it now because it's coinciding with that line. It'll always meet at that point. So let's finish the sketch here. So we've just created another sketch here. Actually, I want to go back and edit this sketch, right? So you see what we've been doing here? If we go back into the here, we can just go. So we first started with a sketch. Oh, also remember, we can't see the sketch because it's unchecked. So we want to check that. Now we can see the sketch. It's useful because if you do more extrusions in the future, you can extrude with the same sketches. So don't forget that. So we want to edit this sketch feature right here. We're going to double click this, and then we're going to add a fillet to the sketch. Instead of doing it with when it's a 3D object, we're going to do it when it's 2D. And usually this is better to do, in my opinion. But actually, no. Scratch that. Usually it's not a good practice to do it in a sketch because you don't have control over it. You can't go back and edit it. You'd have to go into the sketch and manually edit it, which is a pain in the butt or ass, whatever you prefer. So let's hit this one, let's hit this one, and let's make it 4, 5, maybe 6. You can go, like, if you go 100, it's gonna go bleh. So don't do that. So just go 6 or 5. So there you go. We can hit finish sketch now, or we can hit here or hit here. So there you go. By the way, this right here, I was talking about imagining a point. This is what I was talking about. So this curve, this radius is imagine a circle around that point. That's what's going on here. So right here, we're going to do an extrusion, and we're going to do based. So for the, here's another thing. So when we're doing the start for the extrusion, see where it says start? It's going to start directly from the sketch. But if we do offset plane, we can do an offset. Let's do -5. So it's going to make a copy of this and move it -5 in the space. And what we can do now is do a -5, right? So now it's going to do an extruded cut that is -5 inside. You can't see that, can you? Let's just do that. So you see this? It's going to do an extruded cut, and I'm going to make that 10. No, -10. Well, you see that? Yeah, there we go. It wasn't showing it earlier because there was no way for it to be perceived, because it would just be inside of it and you wouldn't see it at all. So yeah. So basically what we're doing is we're taking the sketch here, and with the offset plane, we're taking this the same one, but we're moving it -10. And then based off of that sketch, we're now doing a profile plane on the offset. And so now we have this. Look, there's a random hole, and I think I broke the sketch. Nice. Wait, no, I didn't. It's just because I did a shell operation. If it wasn't a shell operation, it would just be solid. So yeah, that's cool to know. All right, let's do a new document. Let's do some sketch tips real quick before my time is out. Actually, I think that was most of the stuff that I wanted to teach, because that was a lot of the basic stuff. I'll go over one last thing. So I like using lines a lot, in construction lines especially, because you can do stuff like this. Let's just create a construction line. So because of how I laid it out, it automatically knew that I wanted it to be horizontal forever. And we hit L again, or actually, I think you can right click, you can repeat the line, you can, oh yeah, this is right, I forgot, you can, it's been a while since I've used the pie chart, because I don't use this software very often. I use SolidWorks. Anyways, we drag it down. So what it's about to do is add a coincident point where this construction line and the other construction line meet up. There's also going to add a perpendicular, because you can see the 90 degree, or the 90 degree symbol in the top right there. And it's also going to make it vertical. So when we do that, see, perpendicular, it's coincident. Wait, actually, is it coincident? It should be. Oh no, why was I wrong? Let's just hit that. Coincident. There you go. You know it's coincident because you'll see this symbol right here, where it's basically saying this point is on this line at this point, no matter what. So we can't move it up or down, but we can move it sideways. This we can move anywhere. So we need to do that, and then we're gonna do coincident. So we can't move this right or left. We can move it up and down. So sweet. We have this this axis point, like a grid thing. What's the point of this? Well, you see, I love doing this because it saves me time. Let's just make a box. Oh wait, don't make a construction. Remember to turn that off. If you accidentally create a sketch with a construction line, right, like that, you can just select that all and hit the unconstruction. Now it's a normal box. So let's just dimension this based off of this. We're gonna make
Okay, we are letting Kilk know that the audio died, and we'll get this going again.
All right. Check. Can you guys hear me? Basically, what I was just trying to show you was how to do mirror operations, but I guess I'll answer some questions now. All right. Is there any questions? Anybody?
I'm not seeing
Okay,
any right now.
I'm not seeing any. I'm not seeing any right now. The question I was asked was, how do you feel about Inventor versus Fusion or any of the other major 3D drafting softwares on the market, NX, SolidWorks, etc.? I've only used a couple. I've used Fusion, AutoCAD, and SolidWorks. I like SolidWorks over most of them. SolidWorks' UI looks a little old, like Windows XP old, but still I really prefer that over Fusion. The only reason why I'd ever use Fusion is because of camming, because camming is a lot easier in Fusion. Okay. So Fox asks, what's the thing that you most before I go to that question, also another thing, Fusion 360, if you want to use it, you can use it for free for like a year. And that's why I wanted to present it like this, so you guys could take in part of creating whatever you want. All right. So Fox asks, what's the thing that made what thing have you made that is you're most proud of? I made a really, I don't know how to explain it. I helped design a shelving unit sort of thing, and it was like, because I was trying to, it was designed based off of requirements, where there was this like flat sheet metal thing that would hold acrylite bins, or acro bins as they call them, and they're like really cool. And so I had to make it modular. So basically, it was just one flat sheet metal, and you put it on the thing. I also made like the bottoms of it, so you can put Sterilite bins in it. Did custom. I designed custom brackets to hold the steel tubing together. I don't have it on me at the moment. I can show you some other crap I've made. I think. I made this grenade launcher about a year ago. I don't know. I didn't finish it. I was working on making the cylinders. This is like a bunch of random crap. There's other stuff. It's not on this account though, so I'm sorry. The LCD. I should show this at least. This is what the whole talk was. I was doing this for the whole talk, and I barely showed this. So there was a thing that I wanted to show that was important to know. Is when you're building a project, you usually want to build your sketches in a new component, so you can separate from if you have two halves of a case. For the bottom part of the case, what happens is if you don't separate these, when you're making the top and the bottom case, you're just going to have a huge timeline down here, right? There's a lot of operations that went down here, and this would all be combined, and it would be very hard to edit. So what you want to do is make a new component. So I'll just show that right now. Let me go untitle. Let me just do a new design and show you what I'm talking about. So you want to do assemble, new component, and just hit OK. So it's important that you do this, so then you can create a sketch inside this component. So let's say I'll just create a circle. Why not? Right, and then we're finished sketch. We're just gonna extrude this. Let's extrude it by 25 millimeters. Woohoo! And then we're gonna go in here and we're gonna take top. We're gonna do a sketch. We're going to create a line, go here, center, create a line here, center. We're going to select these two lines. We're going to make these construction lines. What we're going to do is make sure this is here, this is perpendicular. We want to make sure this is horizontal and vertical. See, it's going to also warn you if it's already been over constrained. You also want to make sure this point here is coincident, this point is coincident. Sorry, I'm running through it real fast because I just want to show you an example. So you add a circle, put on the line here, dimension it, make it 5, dimension the circle from the middle point, make it like 20. Actually, I'll just make this 25, right? And then what we're going to do is add a we're gonna go circular pattern. We're going to create this, select this object, and the center point is going to be the center, and we're gonna make it 6. There you go. Right. So we've done that. Finish sketch. Let's just do an extruded cut with all of this. And we're just gonna do through all whatever, right? So now this is its own component, and this is great because if we do a new component now, right? Let's just create, okay. Oh, it's gonna put it in there. I don't want it there. We're gonna select the top here and then do new. No, not offset. Select. You want to click the dot here to activate this component. Then you want to do new component. So now it's gonna create its own separate component. We're gonna call this sphere, whatever. And we're gonna call this Jesus. Yeah, whatever. And so now this component is active and there's nothing in it. We're gonna create a sketch on top of it. Which face did it just try doing a sketch on? Sketches. Let's just delete that sketch. Let's just create a new sketch on the top plane. Let's do top. Let's create a box. All right, finish sketch. We're gonna extrude it and make it 45. Right. So the idea here is when the component is active, we can edit this individually instead of having it all be one object, which is a bad thing to do. Don't ever do that. So we have to go back here. Wait, what happened to it? What? I just had it. Did it delete it? I must have deleted it by accident. Basically, so this component's active, this cube is active, we can edit what's in the timeline here, and then in this component, now we can edit what's in this timeline here. It's important that you do that. The other thing you can do is you can join them because they're separate components. So you hit the join, and then we're just going to join it to that face. And just, is it doing it, or is it just being stupid? Fusion! Yeah, just did there. So now it's going to make it the same height and join it there. Yeah. So in other software like SolidWorks, the way they do it is you have separate files. Like if you make instead of having to do what we're doing in here, it's separate files, and I like that system better because they have their own assembly program and it's like so much easier to use. And also there's the drawing stuff. So like let's go to Untitled here. Let's go to the screen here. Let's create a drawing from it, shall we? So LCD board, we right click on that. Let's do, where's the drawing? Create a drawing. And just from scratch, let's play okay. What is it gonna do? Let's see. I haven't done this before. Basically what it should do is it should create a sketch based off of, so this is the base view. This is gonna be the front view. And then what we can do is, I think it's hold control, or shift? Projected view. What the hell? This is so weird. What? I'm sorry, give me a second. This is new to me. So, oh, here we go. So we're gonna do top view. That's a top view. Let's do the bottom view. Oh, the bottom view. Let's just create a new one, and it's gonna be on the bottom. So now that's the bottom view. Except it changed that one. Are you serious? Sorry, give me a second. I'm trying to figure this out. This is a new system. All right, close. So this is the top. This is the bottom. Usually these will be aligned perfectly because you want to make sure this is how they're gonna use this for. Like if you print this out, you give it to an engineer, they're gonna be like, oh, I know exactly what to do. That's also another thing you want to do is make sure you have you like put in your dimensions and what the units you're using, the dates. Another thing they want to do is like add you can pop it is what they call it, I think, where you add text to explain what the hell's going on in this drawing, because sometimes it can be way too complicated to understand what's going on. For right now, for here, it's trying to do the top plate, which is stupid, and I don't like that. This is why I like SolidWorks so much better. The drawing system, in my opinion, is a lot better in there. It also looks a lot nicer. Anyways, I think this is where I hand it off. Thank you for showing up today. So, see you later. Bye. Alright, sorry about that. I don't know if I was supposed to do that. Is that alright?